The limit is x goes to 0 from the positive side of x to the a natural log x, and it does say a is a positive constant. The reason x has to be approaching 0 from the positive side is we could not take the natural log of a 0 or a negative number for that matter. So it only works on the one-sided limit in this case. L'Hopital's rule doesn't apply at this point. However, if you're thinking about putting 0 in, of course, this first piece here ends up approaching 0, but the natural log ends up approaching negative infinity. Got to know what that graph of the natural log is. So it's not L'Hopital's rule form. However, it's pretty easy to rewrite in L'Hopital's rule form. So we can use L'Hopital, I'm sorry, not L'Hopital's rule yet, but we can rewrite it. And instead of having this x to the a here, I'm going to write that in the denominator as x to the minus a. Okay, keep the natural log of x on the top. Keep in mind, we can do that. I just changed the exponent to a negative sign. See, now this denominator piece, as x is approaching 0, that denominator piece, we've got to be real careful, because what does it mean to be a negative exponent? 0 to any power is not 0. 0 to positive powers go to 0, right? But tiny numbers to negative exponents are getting really, really big. And our numerator, we already said, was going to negative infinity. So we can use L'Hopital's rule. And in doing that, rewrite the limit. Derivative of the numerator is 1 over x. Derivative of the denominator, bring down the a, or the negative a, x to the negative a minus 1. Okay? And now we've got to do a little simplifying. And what I'm going to do is I'm going to bring this x to the negative a minus 1 back into the numerator as a positive value. Okay, so this is now going to be x to the positive a plus 1, and then times the 1 over x, all over negative a. And we can do a little simplifying in the fact that here we've got x to the a plus 1 and times 1 over x. Well, what does it mean by x to the a plus 1? Well, it means we have a x's and one more x. Well, that will cancel that x with the 1. So now we have the limit as x approaches 0 from above of x to the a times 1 in the numerator over negative a. Well, now we can actually plug in 0. We don't get any weird stuff going on, and we get a very simple 0. And if we look at the graph of this function, x to the a natural log of x, I used a to be 8, so this is x to the 8th times natural log of x. Certainly, you're getting close to the origin. It's hard to see. It looks like it's tending towards 0. And if you zoom way in, you can still see, yeah, it appears to be approaching 0. So the graph agrees with our solution.